A bit of a trickier question. Find the square root of 1,296. Now, I'll show you two methods. I'll show you prime factorization and I'll show you estimation. But let's be honest, when we did our list of the first 12 prime factors, which were 1, 4, 9, 16, 25, and I'm going to make sure that you know this list. I'm going to write it down every single time. 8 times 8 is 64. 81, 100, 121, 144. Okay, we got to a maximum of 144. This is 1,296. Not as easy. So what we're going to do is we're going to try estimation strategies. Okay, so we knew that 12 times 12 multiplied to 144. I'm trying to find a number that multiplied by itself equals to 1,296. And the only one that we knew so far and felt hopefully extremely confident about was 12 times 12. And that was going to equal to 144. Well, this is way too low. So what we're going to do is we're going to up it. Okay, so I'm at 1,296. What if I did, just for example, a guess and check? Let's do 100 times 100. That's so much bigger than 12 times 12. Now, 100 times 100, 1, 2, 3, 4, 1, 2, 3, 4, is going to equal to 10,000. Okay, so I know that 12 is way too low because 12 times 12 is 144. Now I can see that 100 is way too high. So I'm going to try and find a happy medium. Okay. So if 100 doesn't work, why don't we go with, I don't know, what's kind of halfway really in between these two? Not 50, maybe 40. Let's try 40 times 40. Now I'm just taking two numbers and I'm guessing. Okay. So I know 4 times 4 is 1,600. Ooh, okay, so that's a heck of a lot more reasonable. When we think about 1,296, I'm at 1,600. That is way better than 144 and is way better than 10,000, but it's still too high. Why don't we try 30 times 30? Well, that's 900. Okay, and now we're back down to too low. But at least I'm getting closer to the ballpark. I know that 1,296 is somewhere in between 900 and 1,600. So why don't we try, I don't know, 35? Let's say 35 multiplied by 35. That 35 times 35 is actually 1,225. I'm pretty darn close. I got the 1 and the 2 part. That's good. I got the 96 and the 25. So I feel like I'm a little bit, just a tiny little bit low here. Now we could try 37. We could try 39. We could try 36. I'm going to go with 36 times 36 because I'm not off by very much. So if I take 36 and I multiply it by 36, I get 1,296. Oh, lucky us. Look at, we know that now. So if we know 36 multiplied by 36 equals to 1,296, we also know the inverse operation of 1,296 square rooted. Don't forget, 36 squared is the same thing as 36 times 36. We said that was 1,296. We also said that squared and square rooted are inverses or opposites of each other. And when we square root something, we're looking for what number did we actually find multiplied by itself to get 36. This right here is our key. And that is the square root of 1,296 using our estimation strategy. Let's try using prime factorization. Seems to be helping us in more way than one. So let's remember we still want a number multiplied by itself equaling to 1,296. Now it's giving us a hint here, right? It says use prime factorization. So let's go with 1,296 and pretend just for a minute We didn't know that the answer was 36 times 36. Let's choose another number. I'm going to choose another number that's even. What about 18? Okay, so I'm going to work two arms of my factor tree at once. And I can see that if I took 1,296, divided it by 18, and I took an even number, that's an even number here. Yeah, I just kind of guessed at my even number here. And then I got actually divided by 18 gave me to 72. So now I can actually work two arms of my factor tree at once. I know 18 is the same thing as 2 times 9. 2 is a prime. 9 is not a prime, but I do know that 3 times 3 is 9, and those are 2 primes. Okay. I know 72 divided by 9 is 8, so I know 8 times 9 is going to work here. Neither of those are prime. I do know that 9 is 3 times 3, so that's good because at least I've got a couple of primes there. And 8 is the same thing as 2 and 4. 2 multiplied by 4, I'm sorry. And 4 breaks it down into 2 times 2. So let's write this prime factorization of 1,296 as 2 times 2 times 2 times 2. I think there's 4 of them. Oh, and look at that. It looks like there's 3 times 3 times 3 times 3. There's 4 of those. Now, what we're trying to do is we're trying to find two numbers that are exactly the same. Now, I know it's kind of handy to go, well, there's 4 of these guys and there's 4 of these guys, but isn't 2 times 2 times 2 times 2, what's that? 2, 4, 8, 16. And then 3 times 3 is going to be 9 and 27, 81. These two numbers are not the same. Okay, so we can't group them like this. That doesn't work. That's not smart. But what we do want to do is we're trying to figure out, that's the second time. We're trying to figure out if we can actually get two numbers. So why don't we just get rid of this altogether because we know it's wrong. Two numbers that, let me rephrase that. One number multiplied by itself that's going to add up, multiply to 1,296. So why don't I say if I had a 2 and a 2, and maybe the other two 2s, and we broke those apart into an even group, then I'm going to do the same thing with the 3s. If I do 3 and 3 over here and 3 and 3 over here, isn't 2 times 2 times 3 times 3 the same thing as 2 times 2 times 3 times 3? We can arrange these things all we want, right? Well, isn't that the same thing as 4 times 9? And isn't 4 times 9 36? Same thing over here. 4 times 9 is 36. So what I've done is I've created two equal groups with the actual prime factorizations here. And I can see I got 36 times 36. And we know that any number multiplied by itself can be written as the same thing squared. And I know, that's the third time. I know that any two numbers multiplied by themselves can also have an inverse operation. So for the second time, we found the square root of 1,296 to equal to 36.